Welcome to your dentist appointment 1.5.4. I'm Dr. Barnett, and here we're going to do an operation. Anyway, let's. Do I have chocolate on my chin? I don't know. It's like I've got like drew on a goatee or something. Anyway, let's. I could just restart the video, but y'all are going to live with this. Y'all are going to live with this wondering what it is. I'll report back in the next video. Keep you on the edge of your seat. Let's find some intercepts. Okay. So we know that B is the vertical intercept. And if our line is in the right form, we can always find that, right? We already got it for these ones. But how do we find the horizontal intercept? That usually takes a little bit more work. So what do we know about intercepts, right? The vertical intercept is where it intersects the vertical axis. When the input value is 0, it's going to be 0, comma something. The horizontal intercept, otherwise known as the x-intercept, is where it intersects the horizontal axis. That's going to have an output value of 0. So all your intercepts are going to look like one of these two situations. Either the input will be 0 or the output will be 0. And if you ever forget which one's which, draw a picture. So to find horizontal intercepts, that's where it intersects the horizontal axis, otherwise known as x-intercepts. Right? X-intercepts. This is where the graph crosses the horizontal axis, and if it exists, because it doesn't always, it'll be when the output is 0. Okay, and that's how we find it. Let's do example 4. Find all the intercepts of this function. Well, again, we already know the vertical intercept. It's the b value. It's -3. What's the form of that? 0, -3. Okay. 0, -3. That's on the vertical axis. The horizontal intercept, that's going to take a little bit more work. So we say it's when the output is 0. So we just need to find what input gives us an output of 0. This is like section 1.1 all over again. We know the output. We need the input. Let's solve. So the output is 0. So this thing right here is 0. So let's replace it with 0. This is going to be when 0 equals -3 plus 1/2 x. Now we have to solve this equation. So we can add 3 to both sides. We get 3 is equal to 1/2 x. And then we can multiply both sides by 2. The left-hand side 6. 1/2 of 2 is 1. We get the x is equal to 6. So the input is 6 and the output is 0. These are our two intercepts for this function. So try to replicate that. Pause the video, see if you can find the vertical or y-intercept and the horizontal or x-intercept of this next one. Again, the vertical one, I'm abbreviating more and more every day. That one's simple since it's in the form b plus mx, just a b value. And if you want to be really precise, let's write it as the point 0, 2. The horizontal intercept we have to solve. That's going to be when f of x equals 0. I missed my equal sign. When f of x equals 0, when the output is 0. And again, technically, our function here is called g. Example 4 was f. This one's g. So our function will equal 0. Well, this is our function right here. When does that equal 0? I don't know. We want it to be 0. Let's find what x has to be for this to be 0. So we'll subtract 2 from both sides to get -2 is equal to 3/4 of an x. We have to solve. We'll multiply by the reciprocal. Multiply both sides by 4/3. Hope you like reciprocals. That word's coming back later today or tomorrow, depending on what day you watch the video. So the left-hand side is two fractions multiplied. Multiply their numerators to get 8. Multiply their denominators to get 3. We'll find out that x has to be negative 8/3. So negative 8/3, comma 0. And that's all you really need to do. But if you want to check your answer, a good way of checking your answer can be graphing it. 2 plus 3/4 of an x. Our vertical intercept is at 0, 2. Hey, that's exactly what we said. 0, 2 is that vertical intercept. The horizontal intercept is negative 2.667. Is that negative 8/3? Negative 8/3. Oh, great. It's rounded, but yeah, it's right. Nice. Let me know if you have any questions. Hope your dentist appointment went well. We'll be back in the next one for some ice cream. It's not really ice cream. Bye-bye.